Okay, so this lesson has two objectives. We're looking at section 7.7 in the textbook, and the first goal is to, if we have 2 points, to find the exponential model that passes through them. The second is, if we have 2 points, find the power model that passes through them. Now, I should say something about this first of all. If we look at linear models, a linear model is a line. Okay. An exponential model, we know what that looks like. It increases exponentially. And the third one, a power model starts at 0 and goes up. Often like a quadratic, sort of, except that it goes through 0. These are the three different models. Now what's interesting about each one of these models is that in each case, you only need 2 points to find out what kind of model it is, to find out what kind of line it is. So if I know it's a line and I know 2 points, I can find the equation. If I know it's exponential and I can find 2 points, I can find the equation. And if I know it's a power model and I only have 2 points, I can find the equation. So here, pardon the cold, here, given 2 points, if I know that it's an exponential model, let's find the model. And the second part, if we have 2 points, I know that it's a power model, find the power model. Okay, let's do it. Let's start with the first one. Here's the equation of an exponential model, y equals a times b to the x. And I want to find the exponential model that passes through 112 and 3, 108. So, here's what I'm going to do. I'm going to plug both of these in. The first one I get is 12 equals a. I don't know what a is. I don't know what b is, but I know that x would be 1. And I know that if x is 3, then y is 108. Alright. Now in both these situations, I can actually solve for a. Now I'm going to solve for a here. A times b equals 12, which means that a equals 12 over b. Now I'm going to use this knowledge to substitute back into this equation here. So I go 108 equals 12 over b, because that's what I got from here, times b cubed. Now I just use some knowledge. I have 108 equals b cubed divided by b to the first, 12 times b squared. Okay, we're getting somewhere now. So I'm going to divide both sides by 108. I'm sorry, that's not what I want to do. Divide both sides by 12. The 12's on the right cancel. On the left we have 9 equals b squared, which means that b is equal to plus or minus 3. Now, we're exponential models, we always stipulate that b is a positive number. So in this case, I'm not going to worry about the negative. B will be positive 3. So I know what b is equal to. Now I'm going to use that to figure out what a should be. Okay, so I know b is 3. I need to find a. I know that both this statement and this statement are true. So I can plug 3 into either this equation and solve for a, or I can plug 3 into this equation and solve for a. Now, I'm going to choose to put it in an easier equation. So I'm going to plug 3 in for b in this first equation here. So I have a equals 12 over 3, which is 4. So I know that a is 4, b is 3, y equals 4 times 3 to the x. This is the exponential function that has both the point 1, 12 and 3, 108 on that graph. Let's summarize. Here's what I did. The first thing I did was substitute the coordinates of the 2 points into y equals a, b to the x. So I did a substitution for both. Next thing, I solved for a in the first equation, and I substituted that into the second equation to find b. I solved for a here, and I substituted into the second equation to find b. Then I used b and one of the first equations to solve for a. Okay? And that gave me my solution. So that's how we do it with an exponential model. Let's do it with a power model. Okay. Now a power function, this might require some review, is any function of the form y equals some number times x to any power at all. 18.2. That's a power model. A power model is typically only good for positive values of x. Okay, so this is it's basically similar to a polynomial that goes through the origin every single time and has no other ups and downs. Okay, so it usually has a shape like that or a shape like that, something like that. Okay, so for this particular question, I know that it's going to be a power model, so I've got to have a number up front, and x is raised to some power. The power does not have to be an integer here. And I know that that this passes through 3, 2, and 6, 9. I'm going to use the same idea I used before. So, plug in. If y is equal to 2, then x is equal to 3. And if y is equal to 9, then x is equal to 6. Okay. Again, I'm going to solve for a here. So, I know that a should equal 2 over 3 to the b. So I can use this knowledge now, again, to plug in for a. That means that 9 equals 2 over 3 to the b times 6 to the b. Okay, now we're kind of in an interesting situation. I have to do a little bit more creative algebra here to solve for b. So 9 equals 2 times 6 over 3 to the b, which means that 9 equals 2 times 2 to the b. Now, in order to solve for b here, I need a logarithm. So I'm going to divide both sides by 2 first of all. So I get 9 over 2 equals 2 to the b. Okay? Alright. Now in order to solve for b, I need a logarithm. So I'm going to log both sides. Log of 9 halves equals log of 2 to the b. That means that I can bring this b down and I get log of 9 halves equals b log of 2. So b will equal log of 2, log of 9 over 2 divided by log of 2. And here we need a calculator. So, I'm going to do log of 9 over 2 divided by log of 2. So my exponent is 2.169. So b equals 2.169. So finding b took more work than for a power function than it did for an exponential function. I'm not quite there yet though. I need to figure out what a is. So what I'm going to do is I'm going to use this information and either this equation or this equation, doesn't really matter which one, to find a. Now I think it's infinitely easier to use this equation, so I'm going to plug b in here. So a equals 2 divided by 3 to the 2.169. And again, I have to go back to the calculator. So I'm raising 3 to that power. So 2 divided by 3, put some parentheses in here, divided by 3, to that number. So a is 0.184. So my model ends up being y equals 0.184 times x to 2.169. Okay? Let's recap. So again, this is almost exactly the same as for the exponential model. We substitute in both points. We solve for a in the first equation and substitute that into the second equation. then we use b and one of the first two equations to find a. That's it. Okay, so the whole point here was to use 2 points to either find an exponential model or a power model. All right, thank you guys.